Now here comes question 16. Given that Px is a polynomial of degree 4 and Pn equals to 120 over n for each of the n 1, 2, 3, 4, 5. If so, what is the value of P6? Note that Px plus 1 minus Px is also a polynomial of degree 3. Let d4 to be equal to Px and dnx equals to dn plus 1 x plus 1 minus dn plus 1 x. So we can see that if dn plus 1 is a polynomial of degree n plus 1, then the difference here will be a polynomial of degree n. So we start from Px, which is a degree 4, take the difference of Px plus 1 and Px, we will obtain a polynomial of degree 3. After that, we continue to do the same thing to get a polynomial of degree 2, followed by degree 1, and followed by degree 0, which is a constant. And from there, work backwards to get the value of P6. I'll write these important notes here. So we'll build a table where this is x, this is d and x. When n equals to 4, d41 is equals to 120. d42 it is equals to 60, d43 is 40, d44 equals to 30, d45 is equals to 24. We also find d46, which is still unknown to us. Next, we'll look at n equals to 3. Given using this relation, d31 will be equal to d42 minus d41. That is 60 minus 120, negative 60. The next one will be negative 20, negative 10, negative 6. So we can continue to fill in the blank. So this is 40, 10, 4. N equals to 1, negative 30, negative 6, n equals to 0, 24. Now, when you reach this, this will be a polynomial of degree n. If it's a polynomial of degree n, then it is a constant polynomial. So when x equals to 1, it is 24. It will be also 24 when x equals to 2. So we can fill it, and this is 24. Now, we do backward. Something minus 6 equals to 24. So the answer for this will be the sum of these two, that is 18. The value of this is sum of these two, that is 22. Sum of these two, 16. Sum of these two, 40. And this means that P of 6 is equal to 40. So this is our answer for the question 16.